Alright, so the first question I want to go through is question 13 from Module 5, which is simple word puzzle, and it's asking us within a vector, within a character vector, to find the location of the word banana. And as you might notice, this question is pretty similar to question 1 from quiz 2. In that case, it was just asking you to count the number of times the word MATLAB appeared in the word sequence instead of finding the location of the word MATLAB. But the process to solve these two questions are very similar, just the action that you perform is different. One is counting the number of words, one is finding the word location. And the reason I wanted to mention this is in quiz 2, a lot of people solved this question, solved that question doing something like this, where you essentially spelled out the word. You were saying if you had a for loop statement going through the vector, but then you were saying if the vector at the ith location is equal to b, and the vector at the ith plus 1 location is equal to a, and then so on, spelling out the word. However, this method only works for the word banana. If all of a sudden this word was something different, your code wouldn't work anymore. So I want to show you the method that can be used for any word, and that's the method using test location. So it's going through your vector, your row vector, finding a test location, which is a smaller vector within the larger vector. So you'd be looking at, in this case, 6 letters, and seeing if banana is located here. And then if it isn't, you move down, you check the next, and so on. And then if you find the word, so if the vector at that test location is equal to the word, you perform some action that you desire. So let's take a look at this question and start writing the code for it. So in this case, I want to find the word location, but again, like in quiz 1, it could have been to count the number of words. I would just have to change the action that I'm performing, but I start off my code the same. So in this case, because I am looking for the word location, I'm going to initialize, oops, I'm in caps. I'm going to initialize my word location, and that is going to be zeros, and it's going to be 1 by the size of the word, which in this case has already been defined for me, which is num banan, and that's doing numl and then word banana. So word banana this is being changed into a double vector, and so this is counting how many letters are in the word. So this is from 1 to num banana. And then that's initializing my word lock, and then I'm going to start my for loop. So my for loop, I'm going to use II, and it's going to go from 1 to num sequence, which is, as we can see here, num sequence is 30, so this is how long my vector is. And I'm going to subtract the number of letters in the word, and then add 1. So this is telling me how many times I can search for my word, since it's 6 letters long, and so if I'm at the last letter in the sequence, I can't find a 6-letter word after. So this is telling me how many times I can go through my sequence. And then I'm going to initialize I'm going to set up my test location, which is going to be the indices that I'm checking. So this is going from II to II plus the number of letters in my word, and then minus 1. And again, since this isn't hard coding, numbanan is taking the number of elements of the word. This isn't hard coding, so this would work for any word that I was taking the number of elements of. And I'm going to say if is equal, and in my word sequence, which is my character vector here at the test location, so this is the word I'm testing, since test block is giving me an index. If this is equal to the word I'm looking for, so if this is equal to word banana, then I'm going to perform my action. And in this case, my action is to find the location. But like I said, your action could be different depending on what the question is asking you. And so then my word lock is going to be equal to my test lock, in this case, since I am trying to find the location of my word. I'm going to end this, and let's run my script. Oh, I have an error in line 16. Oh, I'm missing an equal sign. Let's run this. Oh, and I put an extra end because I wrote my end out at the beginning. Okay, let's try this again. All right, let's run it a few times. That looks okay. Let's copy this code into Grader and run it and submit it. All right, so everything looks good. So those are the key takeaways I wanted you guys to get from this question, and consider how you solved the first question from quiz 1, and think about how you could do it in a more general way. Now let's move on to the next question. Alright, so the next question I'm going to go through is question 3 from Module 6, which is about array operations with built-in functions. Built-in functions and learning how to vectorize your code is really important for quiz 3, so making sure you understand how relational and logical operators work with array inputs is really important, so that you're able to vectorize your script and use these many of these important built-in functions. So for this one, I'm just going to solve A, B, C, and D. I'm not going to go through E, but let's get started with part A. So we have an n by n matrix, sorry, a 2 by n matrix with values from 1 to 40 called mat1, and we have a vector that is 1 by 100, and it's with values from 1 to 100, randomly generated. So let's look at part A. Part A is asking us to create a variable called isThere39 that contains a logical value. The value is true if there exists an element greater than or equal to 39 in mat1, otherwise assign the variable false. So this variable isThere39 is looking for one single output, either true or false. So we know we want to have some output that is either true or false for this variable isThere39. But how can we get to that? First, let's see which values are greater than or equal to 39 in mat1. So if I do LG39 and I set that equal to mat1 is greater than or equal to 39, what would this give me as an output? This is going to be an array of the same size as mat1 that is filled with logical values. So if I run my code and I open up mat1 and I open up LG39, I see that this is a 2 by 20 logical array, which is the same dimensions as my mat1. And where my value is greater than 39, I have a 1. And where it is less than 39, I have a 0. So this is telling me all the locations. So anywhere I have a logical 1, it's telling me the location of a value that's greater than 39. but I want my output for is there 39 to just be either true or false. If there are any values greater or equal to 39 in mat1, I want this to be true. And if there aren't any values that are greater than or equal to 39 in mat1, I want it to be false. So what I'm going to do is I'm going to use the any built-in function. And I'm going to say any and my LG39. And if I run this script, then I see my is there 39 right now is a 1 by 18 logical vector, and my LG39 is a 2 by 18 logical vector. Something is still wrong. I wanted my is there 39 to just give me one single output, either true or false, so just a 1 by 1 logical value. But why didn't it do that? The any built-in function is, like a lot of other built-in functions, is going to automatically check just the rows. The columns. So right now, my 2 by 18 became a 1 by 18 since the any function is checking, okay, are there any trues in this row or in this column? No, so I'm going to assign false. Are there any trues in this row? Yes, so I'm going to assign true. And so on, it goes through all of the columns in this vector. But I want to see if there are any values greater than or equal to 39 in all of mat1. So therefore, I want to check that for all of LG39. So what I'm going to do is I'm going to put here a colon, and this is telling MATLAB I want to check all the values in LG39 to see if there are any that are true. And now when I run my script, I see my is there 39 is the output I was looking for, a single true or false. So it's important to remember the syntax for these built-in functions and how they work. If, if we specify either the column direction, the row direction, or if we specify to check for all elements in a matrix. Awesome. So let's move on to part B. Part B is asking us, so it's saying mat2 is copied from mat1, then all the elements that are larger than 10 in mat2 are replaced with 20. So first let's copy mat2 from mat1, and then what we want to do is we want to replace the values that are larger than 10 with 20. But how do we do that? First, let's think about maybe finding the values that are equal to 20, finding the values that are greater than 10 within our mat2. So if this is mat2, if we perform this relational operation on mat2, these relational operations can they work on array inputs. So what this does is it compares every element in mat2 and sees if it's greater than 10. So it compares this element, is this greater than 10? Yes, so I get true. Is this greater than 10? No, I get 0. This is greater than 10, this is greater than 10, so I get logical ones or true values in the index locations where the element is greater than 10, and I get 0 where it's less than 10. And my output in this case is a logical array. And this is the important part to remember about vectorizing your script or using these built-in operations is these relational operations work on array inputs, and they give you an output, in this case, that is also a logical array. And then what we can do is we can use this logical array as an index within mat2 to tell us we want to replace the values at these locations, because we know they're greater than 10, with the value of 20. So I'm saying at the locations where this is true, since this is my logical array, I'm using this as an index in my mat2, and I'm saying I'm replacing that value with 20. So wherever there's a true, it's saying, okay, this location is now getting replaced with 20. This is false, so this location stays the same. It's not getting replaced with 20, and so on for all the elements in the matrix. So let's code that. What I'm going to do is I'm going to write a variable called over 10, and that's going to be equal to mat2 is greater than 10. And I'm going to use that as my index. So I'm going to say mat2 at the locations over 10 are going to be equal to 20. And that's going to replace those values with 20. Let's move on to part C. Part C is asking us to create vec3, which is copied, that is copied from the second row of mat1. Then all the elements in odd locations are replaced to 20 if they are larger than 10. So let's start out with that first part. So vec3 is equal to the second row of mat1. So that's going to be mat2 and the second row. Okay, and now let's first find the values that are larger than 10 within this row vector. So what I'm going to do is, again, I'm going to create a condition. In this case, I'm just going to call it condition 10, since I already used a variable called over 10, so I'll just use something different. And I'm going to see where vec3 is greater than 10. And now if I run this script, I have my condition 10 is a 1 by 19 logical vector that's telling me all the locations where vec3 is greater than 10. But what I want to do is I want to say that the elements in the odd locations of vec3 are replaced with 20 if they are larger than 10. So now I know what elements are larger than 10, but now I want to find the elements that are larger than 10 and also at the odd locations. So what I'm going to do is I'm just going to set all the values in the even locations in my condition 10 vector equal to 0, because I'm going to use this condition 10 as an index to say what elements in vec3 I want to replace to be equal to 20. But what I'm going to do is I'm going to say my condition 10 at the even location, so I can access that by saying I start at the second element and then I skip over 2 and I go all the way to the end, and I'm going to set that equal to 0. Even if those locations happen to be greater than 10, I don't want to access them and I don't want to replace them with 20 because they're not in the even locations. And then, like before, I'm going to use my condition, so my logical vector, as an index within my, this should be vec3, within my vec3, and I'm going to set that equal to 20 because I want to replace the values in those locations with the value of 20. So if I run my script and I open up vec3, and I open up my mat1, this is the second row of mat1, so I know this is an odd location, but it's not greater than 10. This is an odd location and it's greater than 10, so let's see if it was replaced with 20. And yes, it was. This is a and see my mistake. I accidentally took the second row of mat2 instead of mat1. That's why things were incorrect. So here, let's take a look again. So I've replaced, this is asking for the second row of mat1, not mat2. So some values were already 20 because we've already replaced values that are equal to 20 here. So here, if I look at my mat 1 in the second row, this is a odd location. It's greater than 10, so it should be replaced with 20. Even location, we don't worry about. Here again, it's an odd location and it's greater than 10, so it was replaced with 20. So everything looks good for part C. Now let's move on to part D. Part D is asking us to find the maximum sum of pairs. So what we want to do, if in this case our vec1 is a 1 by 100 vector, so that means we'll have 50 pairs, and so we want to add these pairs together and then find the max of them. And what we can do is we can think about reshaping our vector. So if this is our example for vec1, we want to get these pairs next to each other somehow. And to do that, we can use the reshape function. So we know we have 3 pairs here. So if we reshape our vec1 into a 2 by 3 matrix, then what we can do is we can easily sum up the columns to find our sum of pairs. But what if we, instead of making it a 2 by 3, made it a 3 by 2? Would that also work? In this case, it would not work, since even though you would have 2 values in the rows, reshape uses linear indexing order. So it would actually assign these values. It would go 1, 2, 4, 5, 4, 2. And then if you tried to sum up the rows, you now have the incorrect pairs in this case, because when reshape is doing its work, it is reshaping this vector according to linear indexing order. So it always goes down in columns, which is why this does not work, and we had to reshape it so that we would add up the columns instead of the rows. So let's write out that code for part D. So I want to label this max sum pairs, but before I find the sum of my pairs, I have to reshape my matrix. So I'm going to call this mat reshape, and I'm going to do reshape vec1. And like I said, I'm going to make it, in this case, in that example, it was a 2 by 3, but we know we have 50 pairs in this case, so it's going to be a 2 by 50 matrix. And then what I'm going to do is, if I want to find my max sum pair, I know I'm going to use my max function, and then I'm going to want to find my sum of pairs. Right now I have it as a matrix and I want to sum up in the column direction, so I'm going to use sum, and I'm going to put in my mat reshape. And because I want to sum in the column direction, MATLAB, if I don't specify a direction, is automatically going to sum in the column direction. But so that I'm aware that I am summing up in the column direction for myself when I'm looking at my code, I can also specify that I want to do this in the column direction. Okay, so let's run this code. And my max sum pair is giving me one output, which is what I wanted, which is one single scalar value that's giving me maximum. All right, so let's put this code into grader. Obviously, I'm going to get an X for part E since I didn't solve it, but let's see if the other portions of my code are correct. And the other portions are correct. So let's move on to the next question.
The last question I'm going to be going over is question 29 from Module 7 called Word Score. So let's take a look at what this question is asking us. Create a function called Word Score that accepts one input, char vec, and one output named score. So this is our function syntax. Char-vec is a character vector containing lowercase letters, symbols, and uppercase letters, and only uppercase letters have the following scores. So A would have a score of 1, B would have a score of 2, and then all the way to Z, which has a score of 26. And again, only lowercase letters have a score. So here the score for MATLAB is shown. That's when it's spelled in all lowercase letters. Here, when it's spelled with an uppercase M, this does not have a score, so we start with the score for A plus the score for T plus the score for L and so on to get the total score for the word. And here, as we can see, the capital H, the exclamation point, and the capital M don't have any scores associated with them, so we would just calculate the score for the lowercase letters. And this was the given script, which I copied over, and now I'm going to copy over the function syntax. Oops, sorry. This part is not, you're not able to copy over just the given script, but we'll write out our function. Score is equal to word score, and the input is char-vec. And I'll write my end statement already. So an important thing to note about the given script, so here we have our test char-vec, which is the character vector that we want to find the score for. And here we are calling our function in this line. So we have our output variable test score, we've called our function word score, and then here's our input test char-vec, which is the character vector we want to find the score for. An important thing to note is that the input and output variable names are different when we call the function here and here when we're defining the function. And the reason for that is when you're creating, in this case, a local function, the purpose of a local function is reusability. So when we're calling this function, we can call the output whatever variable name we want, and we can call the input whatever variable name we want. We just have to make sure we've defined our input. In this case, we've defined our test char-vec with this character vector, and we've assigned our output as something, and we're calling our function, and the function that we're calling, our local function, is written below the script. So this is our script, and then this would be our local function that we're calling, and that always has to be written underneath the script, the function. But the important thing, let's see here, you can see that my input and my output, when I'm defining my function, have an underline. And if I highlight it, it says the function return value score might be unset. And same with my here, input argument char-vec might be unused. So what this means is when we are defining our function, we have to make sure that we include this input somewhere and we define our output. And that's how, when we call our function again in our script, when we call this function, MATLAB knows what to do and how to calculate this output. We have to define this output within our function using this variable name in the function, and then we can use any other name when we're calling the function in our script. So that's the really important thing to remember about functions and how we use and write local functions. Okay, so now that we have that out of the way, let's start solving this problem. So first, let's convert our character vector into doubles to make it a bit easier to work with. So I'm going to define a variable, I'll call it double vec, and I'll just typecast this as a double. And again, I need to include the input for my function that I've defined here in my function definition. I'm not going to put in test char-vec inside here when I'm defining my function. So that's important to remember. So now that I've converted my character vector into a double, the next thing I want to consider is finding out what letters are lowercase and what letters are uppercase. So to do that, what I'm going to do is, so first, right now I've converted, let's say I have this as my character vector. I've converted my character vector into doubles based on the ASCII table. So here I have my lowercase letters starting at A, which is 97, and Z, all going all the way to Z, which is 122. And then also sometimes in my character vectors I might include uppercase letters or symbols, but those just don't have a score. So here my uppercase letters go from 65 to 90. And so this character vector would be converted into these doubles. And let's say I wanted to locate where my lowercase letters were, since those are the letters I want to assign a score to. So I would want to get some logical vector that looks like this, that tells me which elements are lowercase letters and then assign true to those, and then the letters that are uppercase or maybe a symbol, so any non-lowercase, I would want to assign false to those locations. And how I can do that is by using some operators and some vectorized code. So I'm going to create a variable called lgvec for my logical vector, and I know if my letter is lowercase, it is going to have a double value between 97 and 122, since that's my lowercase letter range in the ASCII table. So what I'm going to do is I'm going to say my double vec that I defined has to be greater than or equal to 97, and it has to be less than or equal to 122. And notice here I have used a single AND operator because my double vector is a row vector. And so when I perform this relational operation on it, I will have a logical vector in this case, and I'll have a logical vector in this case. And so because I'm working with two arrays, I have to use a single AND operator because the double AND operator only works on scalar values. And so this gives me a logical vector that tells me what values are lowercase. So what values are between 97 and 122. And then what can I do to get the score of my lowercase letters? I can use this logical vector as an index. So that's the important part about vectorizing your code and using these operators on arrays. This logical vector I can now use as an index inside of my dbvec, which will give me the lowercase letters as double values. So here, wherever, since I'm using it as an input, wherever I have a true, it's going to extract that the element in that location. This is false, so this doesn't get extracted. This is true, so this gets extracted. This is true, this gets extracted. This is true, so this gets extracted. And so then I have a vector containing just my lowercase letters. And now, so let's write out that piece of the code, and then we'll think about how we can calculate the score for it. So I'll write out my variable lower letters, and I'll set that equal to my dbvec, and then I'm accessing my lgvec here. So this is giving me the lowercase letters within my vector. But now I want to figure out the score. So let's take a look at our lowercase letters and how we can figure out the score for them. So in this case, we know that the ASCII table values for lowercase letters start at 97 and continue to 122. And we also know, so 97 means A, and we know that we want the score for A to be 1. So what if we subtracted 96 from this vector? Which would mean subtracting 96 from each element in the vector. This becomes 1, this becomes 3, 4, and 5. Are those the appropriate scores for the letters? We know A should have a score of 1, B2, E3, D4, E5. And that's exactly what we have. So here we have A, which is the score of 1. B was uppercase, so that wasn't included. C has a score of 3, D has a score of 4, and then E has a score of 5, which is exactly the scores we wanted. So we can actually get the score for the letter by subtracting 96 from our vector. And then all we have to do is sum this up, and that gives us the total score for that character vector. So what I'm going to do is I'm going to write out my variable score, and this is my output. So right now I'm defining my output for the function so that whenever I use my function again, so whenever I call my local function here, MATLAB knows how to calculate whatever value, whatever output variable I assign. So we know that we're calculating this output in this way. So, and I have to define my output when I'm creating my local function. So I'm going to say my score is going to be equal to the sum of my vector lower letters minus 96. So that would subtract 96 from each element in the vector, and then I'm summing them up, which will give me my total score for that vector. So if I run my code, as you can see in my function, none of the variables within my function are printed in my workspace. Only the script is printed. If I really wanted to see what the output of these variables were to make sure I was on the right track, what I can do is I can comment out my function, and I will temporarily I will also comment this out, and I'm going to temporarily change this to the same input as I have here. So I'm going to temporarily change it to charvec, and now I can see what the outputs are for the variables that I used within my function if I do want to check to make sure my function is getting calculated the way I was hoping it would. So now I can check, okay, what are my lowercase letters? Let me open up my character vector. Are these the lowercase letters I wanted to assign? Let's take a look. So I know T should be a lowercase letter that I have included. If I look at my ASCII chart, T has a value of 116, and I have 116 here. So things are looking good with the outputs for my for how I am defining my function. So now, once I did that, I want to very carefully return this back to how it was before, after I've checked my outputs for the function, and include my script again. Again, this is optional if you are wondering if your function is correctly working, and I would really suggest practicing with this, because otherwise doing it for the first time on the quiz I wouldn't necessarily recommend if you haven't practiced commenting out your functions, checking to see the outputs for these variables and all of that beforehand, because it could leave some room for error. But it is something I would suggest that is helpful for the debugging process. So now we've written all of our code. Let's copy our function and paste it into Grader. Make sure everything is correct. And we've passed all of our tests. Awesome. So I hope you found this review video helpful for quiz 3. I definitely suggest going and practicing those that list of tutorial questions I made and making sure you're reviewing all of your homework and the past quizzes. And best of luck on quiz 3. You guys are going to do great.